Okay, just a few questions to cover for the last tutorial. Let's continue. Okay, I think we have discussed until the advantages and disadvantages for different type of renewable energy compared to the other. Okay, let's continue with question number two. Just let me know if you are not here. Okay, question number two. If Terengganu decided to switch completely to wind energy and using the wind turbine with the rotor blade diameter of 126 meter, an average wind speed of 2.9 meter per second, and air density of 1.23, and 30% of overall conversion efficiency, what would be the total wind energy per year per turbine? So for this case, it's just to calculate the total kinetic energy available for the turbine. Okay, so as we know, wind energy is come from the kinetic energy. Okay, kinetic energy equal to 1 over 2 mv squared. Okay, and also equivalent to 1 over 2 rho v rho g a v cube. Okay, density, and g is the gravitational force, and a is a volume. Okay, maybe you look in this way. So first we get a kinetic power, which is equivalent to 1 over 2 m dot v squared. Okay, and the mass flow rate can become the volumetric flow rate times the density. Then v squared. And then the volumetric flow rate can become rho a v cube. Okay, so now we want to find the total power first. 1 over 2, density 1.23, area refer to the total swept area of the turbine. So diameter 126, pi r squared, r speed 63, velocity 2.9 cube. So you will get P of the wind. Which is equivalent to 1870.25 watt. Okay. Then we can convert to 1 year. We want to get the total energy for 1 year. So we get the power times the 24 hour times 365 days. So we get the total we have is 16.491. Is that true? Wait now, calculate wrongly. My answer is 16.38. How about you, Endo? Mega watt hour. We don't need to calculate, we don't need to multiply the conversion efficiency yet. because this just asks for the wind energy. Okay, not the electricity, just wind energy. If they ask for the how much total electricity you can generate, then you only multiply with 30. Okay, then we go to number B. How many wind turbine will be necessary to meet Terengganu daily demand of 800 megawatt? Okay, so 800 megawatt, but now our power is 1870.25 for 1 wind. So how many turbine? So you should take the total required power divide by the total power and the wind turbine can generate. 1870.25 watt times 0.3. So this will give you the available number of power or number of turbine you need. So you need a lot of turbine. To power up entire Terengganu, I need this amount of wind turbine. Okay, Kashin, A, we didn't multiply with efficiency because they asked for what would be the total wind energy, just wind energy. Okay, it's not, okay, you can see that the wind energy will be hours absorbed by the blade, convert to mechanical energy, then only be the electricity. But now they ask for the wind energy only. Did not really ask for the electricity. If they ask for total power output or total energy output, also refer to the electricity because the output. But now this question is specifically state wind energy. Okay, so we just measure how much energy we have in the wind. Okay, then number C, sorry. What will be the cost of energy per kilowatt hour if the capital and operating cost of each turbine is 30 million and the lifespan is 20 years? So cost of electricity, cost of energy. So the units will be in terms of 1 kilowatt equivalent to how many cents, something like this. Okay. So first we need to measure the cost. So operating cost and turbine is 30 million. So cost of electricity should be cost per output. Okay. So the cost is 30 million. Output power for 20 years is, so you can see that one turbine is 1870.25 watt times 0.3. So this is a power output. And now this is the average power output, which I will run it for 24 hours a day, 365 days a year, and for 20 years. Okay. So the cost of energy is 305 per kilowatt hour. It's totally too expensive if you want to build this in Terengganu. As you know that to have a cost-effective wind turbine, the wind speed. When there, okay. Wait, let me check again. How about the rest? What answer you get for A? Yes, I see. Yeah, sorry for that. So 187,025. 187,025. Okay, then you make the necessary adjustment for B as well. Huh? Excuse me. 187,025. Then number of turbine. Just 14,258. Okay, and then cost of energy, I think should be 3 ringgit. The current generation cost of the electricity in Malaysia is just about 15 to 20 cents. But this one need 3 ringgit. Okay, so I'll say that too expensive lah to use this. Okay, so we get the cost of energy, which is 3 ringgit and 5 cents per kilowatt hour. Of course, we still can do it just because if we didn't start, we will never have wind energy in Malaysia. But now we start with the first one with 3 ringgit and 5 cents per kilowatt hour. Yes, it's very expensive, but first it can improve the. Okay, I see that in some of your assignments you're doing wind, but of course, if you build the wind power plant in Malaysia, of course you won't earn money, you won't have profit. So what is your targeted? What is your objective to build it? Not to earn money, but to improve the awareness. Okay, to research. Okay, you can see that Euro country, Japan, China, they always looking for new technology, for wave, for tidal. They try, but of course they won't earn money. They try see whether it's possible to improve and to make it more efficient in the future. For example, as I say that the photovoltaic panel initially is very very expensive. Okay, it's totally not worth for mass production. But after a series of improvement, then it become quite user friendly and quite cheap. I would say that you can able to compare quite affordable and able to compare with the price of the fossil fuels. So we need research. But before the research, we need to build the first uh, wind energy uh, power plant in Malaysia in order we can carry out the research. Okay. But of course, it costs a lot of money. Okay, then let's continue with question number 3. Question number 3 to 13 is actually all theory question. No calculation anymore. What is the environmental advantage of using biomass as an energy sources? What's good about using biomass? What's good to environment? Carbon neutral, yes. So carbon neutral is mean that it won't generate extra carbon dioxide. So it's good for environment. It reduces the greenhouse gas, it slow down the global warming. Remember to explain further how this carbon neutral will affect the environment. What else? Okay, you also can talk about the waste. The use in biomass as an energy source reduce the waste, either the plantation waste or municipal solid waste. Okay, so if you reduce the waste, you will make the environment greener. So of course, it have the environmental advantage to reduce the waste. And third, if I use the biomass, I can have a less dependent on the fossil fuels. And this definitely have the environmental advantage where I do not need to explore or harvest for the new fossil fuels, which is very bad for environment. You dig a hole somewhere and there's a danger of the maybe oil leakage or something like this. Okay, so these are the environmental advantages of using biomass. First, carbon neutral. Second, reduce the waste. Third, reduce the dependency on the fossil fuels. Anything else I missed out? Maybe you can say. We can discuss. Okay, yeah, but try to link back to the environment. If the question just asks for the what is the advantage of using biomass, then it's much easier. But this one, everything must link to the environment. Okay, then no issue. Then move to the next one. Do biomass power generating units help combat global warming? So yes or no? If yes, how is do it? No. Okay, first, what caused global warming? Global warming caused by the greenhouse gas. So you have to think that does this biomass power generating unit able to reduce the greenhouse gas? If yes, then it will help to combat the global warming. Yes, again, carbon neutral. We know that biomass is carbon neutral. Is not release extra carbon dioxide. So carbon dioxide is one of the greenhouse gas which able to hold the heat. Okay, so you reduce the greenhouse gas, sorry, you reduce the carbon dioxide, you help to combat the global warming. So I would say that biomass power generating unit help to combat the global warming. Okay, I know that maybe some of you will have the idea, oh, you use the biomass, actually you have a burning, and burning create a lot of heat, and actually you increase the global warming. Not that case. Global warming is nothing to do with the open burning or what. Global warming is actually just trap of heat from the sun. Imagine that the amount of the heat from the sun is much much higher than your open burning. No issue at all. You use a biomass power generating unit. As long as the heat can dissipate to the space, okay, to the outside atmosphere, then good enough. So the problem is the atmosphere itself trap the heat. Okay, the global warming is because the atmosphere itself trap the heat, not because of the burning or what. Okay, go next one. What technique can be used for improving the quality of biomass fuels? So first, when you talk about improving the quality of biomass fuels, you need to know what's the problem of biomass fuels. Biomass fuel has a low energy value. Biomass fuels is difficult to handle because solid form and they have the different composition. Biomass fuel is very fat, high water content. Okay, so these are the problem of biomass fuel. So which one you can improve? Are we able to improve the calorie value of the biomass fuel? I don't think so. But you can improve the energy density of biomass fuels. Okay, how to do that? First, you have to remove the water content. In order to use the biomass fuel as a burning fuels, first thing you need to evaporate all the water vapor, water content. To do that, you need a huge amount of energy. But if the biomass fuel itself already in a dry condition, then it automatically will have the higher burning power. Okay, and then secondly, biomass fuels have low quality because it has a low density. Okay, low energy density. So energy density is something like how many power you can have or how many energy you can have per unit volume. So how can I do it? I can compress it to be the smaller size so that you have the higher energy density per unit volume. Okay, so normally how they do it first, they will convert these biomass fuels, solid biomass fuels into the pellet. Pellets is made from the something like sawdust. They cut the biomass fuels into the small pieces like sawdust, and then they dry it. Okay, and then after dry it, they compress. Why they need to cut into small pieces? Because you need to cut into small pieces, then you're only able to dry it at very effective rate. Okay, a big pieces of wood, normally you take a few months, a few years to fully dry it. But if just sawdust, then maybe it's just a few minutes you can dry it completely. Okay, so this is how we improve the quality of biomass fuel. But remember, the nature of the biomass fuel cannot do it. The calorie value, that thing we cannot do anything because this is nature of product. But we can make it easier to process. Okay, easy to burn at higher burning value. And another method is to convert this biomass fuels to the other form, which is easier to use. For example, I can convert biomass fuel into the syngas. We call it gasification. We can convert to ester. You have the biodiesel, okay, or you can have something else, biofuels. Okay, you can always convert the solid biomass into other fuels which have the better quality, which easy can burn at a higher temperature, can have the better mixture with the air, can have the higher, what to say, sorry, can have the better, easier to transfer in terms of fluid, can be in gases form, can be in the liquid form. Okay, so this will solve the problem of biomass, solid biomass fuels which is difficult to handle. Uh, Bad air fuse mixture, high water content, and so on and so forth. There's many methods that we can do. Okay, maybe you can just explain a few, but this is a tutorial, so I don't really state how many techniques you need to explain here. But the exam definitely will put that. Explain 3 techniques used to improve the quality of biomass. Then you have to state 3. Okay? No issue on number 5. Or maybe you can think of any other method to improve the quality of biomass. Maybe you can share in the chat box. We can discuss whether it's correct or not. Number 6, state and briefly explain the typical conversion process from biomass to useful energy form. So how many methods we have? So first we have the direct burning. Direct burning is just to burn the biomass to boil the water and generate steam. Okay, this is the most direct method, and it's not the most effective but it's the most direct method. And we already have a very major technology to do that. Okay, and what else we have? We have gasification. Okay, gasification is the conversion of the solid biomass into gases form. Okay, this one you can go back to check in the lecture note what's the detail of that. So what else? Combustion, gasification. We have fermentation. Fermentation is an anaerobic process that breaks down the glucose with organic material. Something like we can convert the biomass with the glucose content. You can convert them into the ethanol, alcohol, type of alcohol, and this alcohol can be used as a fuse. We know that alcohol is flammable, easily flammable, so that you can use it as a fuse for anything. Okay, we call it as a biochemical process, convert solid biomass into the alcohol. Okay, and we also have anaerobic digestion, which is the microorganism break down the biodegradable material in the absence of oxygen by the something like landfill lah. So you add the landfill, give some water so that the microorganism can survive and consume or decompose the organic material or biodegradable material. Okay, and what else we have? Um, yeah, we have the biodiesel. Okay, so we have this one you call it agrochemical. We convert oil, maybe some kind of vegetable oil, soybean oil, or whatever oil lah, or palm oil, convert them into the ester, and this we call it as a biodiesel. Okay, the process called esterification. Okay, these are the methods that we can convert to biomass to the useful energy form. But I will say that the direct burning is the most effective way to release all the energy in terms of heat. Okay, because you can see that what I mean is direct burning, you can fully utilize all the energy. But if you convert to ethanol, you convert to other resources, something like biodiesel, yes, the quality of the source that you have, the final product you have is very good. But in the process of the conversion, actually you will destroy some portion of the energy you have in the sources. Not 100% of the sources can be converted to biodiesel or maybe ethanol or maybe gasification, the syngas, because you need the process, and then the process actually consume energy. Okay, so the direct burning should be the best way, I would say. Although the heat itself is low quality because you cannot reach high temperature. Okay, but the process is a more direct forward, and you should have the most higher efficiency. Okay. Okay, the next one. What are the main organic compound of biomass? This is totally depends on the type of biomass you have. We talk about the plantation base. So mainly we have three: carbon, oxygen, okay, and hydrogen. Normally it's a carbon and oxygen. Carbon mostly, most of the biomass have the most carbon, and followed by oxygen, and only the hydrogen. And some of them may have the nitrogen and sulfur or phosphorus, other things, but there's a very minimum, less than 1% of the total composition. Okay, and these carbon, hydrogen, and oxygen is actually can be converted to fuels. You can see that we have oxygen fuels, we have hydrogen fuels, and carbon definitely you can use as a fuels. Okay, but of course not all the carbon. Carbon is very, how to say, the composition is called carbon, but based on their arrangement, atomic bonding, they can make different type of material. Something like diamond is also part of the carbon, but I don't think we can burn it. Okay, because burning we are not able to break the bond of the diamond. Diamond is made from carbon, but the normal burning not able to break the bond of carbon. Okay, so make it not able to use as a fuse. So that actually when doing burning, first thing we break the complex bonding of the material to the simple form. Something like we convert wood into charcoal. Okay, we use a pyrolysis, and this pyrolysis actually to break the bond of the carbon to be a simple form, simpler, so that it's easy to burn. That's why we want to use charcoal. You can see that if you use charcoal, actually you are easier to control the heat and temperature. That's why you use for barbecue. You don't use the wood directly. The wood directly normally will be appear as a fire, and the temperature also will be lower. But you convert to charcoal, then the temperature is quite reliable, consistent at high temperature. Okay. Just stop me out. You can move too fast. Okay, then the next one. What is coal firing? Co-firing refer to, co is referred to together, we firing together, fire together. So this because biomass, most of the biomass have uh, low quality and it cannot reach high temperature during the burning. So it causes it have a very low thermal efficiency. Sorry, it causes have a low thermal efficiency. Okay, so this biomass co-firing is actually adding biomass as a partial substitution fuels in high efficiency coal boiler. We mix 15% of biomass into the coal burner, coal boiler together with the coal. Okay, this case we can reduce the greenhouse gas because partially it's carbon neutral. Okay, and then we still can maintain the efficiency of the power plant. Okay, but the problem is actually it's quite difficult to control. Okay, what I mean is you want to maintain the efficiency of this coal firing is very difficult. It's much difficult than a single coal fire plant. Okay, yes, ideally you can make it almost the same efficiency, but very difficult. Okay, main advantage, sorry, the main idea of coal firing is because biomass cannot reach high temperature. Biomass have low thermal efficiency, so we mix with coal, but the coal itself is not renewable. Okay, so our idea is not fully replace the coal with the biomass, but we just reduce the dependency on the coal fuels. We reduce the coal usage. Okay. Okay. Next, what is the gasification and there is any advantage of this technology? Gasification is the conversion of the solid biomass into the gaseous form. So we have four different process: drying, pyrolysis, what else? Reduction, and combustion. Okay, combustion will give the heat for the other three process, and we are drying just to dry the wet biomass. Okay, and then the pyrolysis is actually to break down the biomass, complex biomass into charcoal. So we break it into the simple form. Okay, and reduction is a removal of the oxygen at high temperature to produce the hydrogen and carbon monoxide. But mainly it's a carbon monoxide we can use as a fuels. Okay. And the next one, number 10. What are wood pellet and what are they used for? Wood pellets come from the sawdust. We compress the sawdust into a pellet form. Pellet form are something like uh, small size. I think maybe I'll show you. Okay, these are the how it look like wood pellet. I normally do for burning. Okay, so it comes from the wood dust, sawdust, and then they dry it, they compress it. But frankly speaking, the wood pellet is much expensive than the natural wood because you can see that actually. Okay, so what they use this for? Maybe just to start up the fire. Okay, but not for continuous burning to generate electricity. We know that it has very high quality, but it's still too expensive. You can see the packing, some they use for pets to absorb their, I don't know, I'm not really sure, to absorb their smell or what, okay, or their pee. Okay, so it's a very high quality biomass resources, but it's still quite expensive, easy to burn. We can use to start up the fire. Okay, and number 11. We are harvesting woody biomass improve or reduce the forest health. Huh. What do you think? Forest health. Will you improve the forest health if you're harvesting the woody biomass? So it's actually quite subjective this kind of question. It depends on how you actually harvest the woody biomass. Okay, if normally you harvest the woody biomass, you provide, uh, you improve the forest health by removing the disease or damage or other tree that cut off. Okay, so you somehow you utilize the space, you clean out the space. So it's something like it's good thing like you clean out the space so that the other tree can have the better space to grow. Okay, but if you remove this woody biomass, actually you also remove the fertilizer because this woody biomass end up with they will decompose by the microorganism and will become the fertilizer, the natural fertilizer for the tree. But now you remove it. Okay, so how actually to explain this? It can reduce or improve, depends on what point you want to cover. It can improve the forest health because you remove the disease or damage the biomass with disease or damage part. Okay, so you can make it grow better. For example, if you gardening before at the home or house, okay, so you keep trying to cut the damaged branches or the branches which have the disease. Okay, so when you cut it, actually the tree will grow in a better way, more healthy. Okay, but same thing, this biomass will actually decompose and become the fertilizer. This I don't know. This I have depends on which one is more dominant. Okay, you remove the disease, you also remove the fertilizer. Okay, so this question is very subjective. You answer it and then explain based on what you can see. Of course, we do not know which one is more dominant because it totally depends on the situation. Okay, so we won't say that, but this one I will accept both answer, yes or no. Okay, yeah. So we improve it because we remove the damage or disease, but we reduce the forest health because we remove the fertilizer. Okay, okay, number 12. We use of woody biomass for energy improve or degrade air quality. What do you think? You know that if I burn the biomass in the open area, it actually will emit a lot of particle, something like nitrogen oxide, carbon monoxide, sulfur dioxide, and some of them even have heavy metal like lead, which is very toxic, and some of them like something like nitrogen oxide and sulfur dioxide will contribute to the acid rain, and carbon monoxide contribute to the greenhouse gas. Okay, so do you think that you burning biomass will degrade air quality? Huh. This is very subjective as well. Depends on how you control the emission of the burning of biomass. Okay. Okay. You see, yes, we always say that we burn the biomass, we get the energy. We don't burn the biomass, the microorganism will decompose the biomass and also will release the carbon dioxide and and water to the surrounding. But remember, these microorganisms will not decompose the heavy metal. They will not decompose nitrogen oxide. They will not decompose the sulfur oxide. But we burn it, these nitrogen and sulfur will have the reaction with the oxygen, okay, to become the toxic gases, something like nitrogen oxide and sulfur dioxide. Okay, which were not caused by the microorganism. So it's not totally the same, but as long as you're able to control the emission from the burning of biomass, then it's good enough. Okay, so you are able to hold this nitrogen oxide and sulfur dioxide, lead mercury to release to the environment, then good enough. Remember, when at high temperature, this thing will become gaseous form, so you will release to the environment. Okay, but for microorganism, this thing will still remain as the nitrogen, sulfur, lead and mercury, and in the maybe in liquid or solid form. Okay, so you won't release to environment, you won't start the this heavy metal into your lung. So it's not have that harmful, I would say. Okay, but if you burn it and you control the emission, then burning the woody biomass actually you reduce the dependency on fossil fuels, whereby you reduce the emission of greenhouse gas as biomass is carbon neutral. Okay, so in that case, you actually improve the air quality. So the use of woody biomass for energy improve or degrade air quality. It depends on how you control the emission. If you properly control the emission, you limit the emission of the burning, then you improve the air quality. If you not control the emission, then actually you degrade the air quality. Okay. Okay. Now my last question. Can a landowner expect to make a lot of money selling woody biomass? Do you think that woody biomass is very valuable or very expensive? No, I don't think so. So selling woody biomass normally won't earn a lot of money, won't make a lot of money. Not like you use your land to build a photovoltaic power plant or build other things. You should earn more than just plant the wood, plant the tree, and sell the woody biomass. Okay, so a good thing of biomass is abundant. Okay, it won't cost you a lot of money, but bad thing is have the low energy quality, so that the transportation cost will dominate the entire process. Okay, so you won't see that they transfer the biomass wood to the power plant. Normally, the power plant will build at where you have the biomass fields, something like palm oil mill. Okay, they will use the empty footprint directly from the palm oil mill to generate electricity. Then it's good enough. It's very good. Okay, so the main disadvantage or main limitation of biomass fuels that convert biomass fuel into electricity is the distance of biomass fuels from the power plant. Okay, and remember that biomass is not concentrated in one location. It's scattered around. Everywhere you have the biomass fuels, but it's not together. It's not collected in one place unless you have the landfill. Okay, so the only two places that you can build the biomass power plant, which is near the landfill or near where you have these plantation waste. Okay. Okay, I think that's all of our tutorial, and this will be the last tutorial. Any question? I think this will be our last class for this semester. Anything you want to ask before we dismiss? And just to let you know that our exam is on the first day of exam, which is the 1st of November. Sorry, 1st of October. Any question? No question. Okay, seems like okay lah. So hopefully you can score. You get a good score in your exam. Okay, so that's all for today. Thank you for your time, and then hopefully I don't need to see you in the coming semester. Okay, thank you everyone, and bye bye.